Assalamualaikum. Hi guys. Today's video is about molar mass. Molar mass is defined as the mass of 1 mole of an element or 1 mole of a compound. Molar mass has a specific units which is gram per mole. You can write it down as G mole to the power of -1. When you got these units, you can understand the specific formula for molar mass can be used to find the number of mole equals to mass in gram over molar mass in gram per mole. So when you calculate your number of mole, you can cancel out the units gram and you will have the units of mole abbreviated as MOL. For your information, molar mass of any substance is numerically equal to its relative mass or average atomic mass or relative atomic mass or relative molecular mass or relative formula mass. So what does it mean by this slide? For example, if you have compound X, the molar mass of compound X is 18 gram per mole, you can say the relative atomic mass for compound X will be 18. Because it is a relative, there is no units. Same goes if you have compound X with 18 gram per mole for the molar mass, the average atomic mass for compound X will be 18 AMU. So that what means by numerically equal. The value will be the same, but the unit is different. Now I'm going to relate the number of mole of any elements with comparison to our carbon-12. For example, I have 1 mole of pure gold. This is a composition of pure gold. And I have the composition of carbon-12, 1 mole. If I want to relate with the mass of 1 mole of gold, you have to understand it is not equal to the mass of 1 mole of carbon-12 because for gold, the mass for it is 196.97 gram. However, for carbon-12, the mass of 1 mole of carbon-12 is 12.00 gram. So please be careful. They bring the same number of atoms, but they will not have the same value for mass. Let's try example 1. I have here magnesium atom. So magnesium atom, if I put the relative atomic mass for magnesium from the tabulam, I will have it as 24.0. So from here, if I want to determine the mass of 1 mole for magnesium, I just put the same value with units gram. Next, if I want to determine the molar mass of magnesium, I know that it is numerically the same with relative atomic mass, so the value should be the same, but the units will be gram per mole. Last but not least, if I want to determine the number of magnesium atoms in 24 gram of magnesium, this is from 1 mole of magnesium, I will write down the value 6.0 exponent 23 magnesium atoms. So this is how you want to relate molar mass with relative atomic mass, with mole, and with the mass. Let's go to the next example 2. I have here a molecule of water, H2O. And from its chemical formula, you know that the relative atomic mass for hydrogen is 1 and relative atomic mass for oxygen is 16. So to get the relative molecular formula for H2O, our water, you have to add up 2 hydrogen and 1 oxygen atoms. Based on their relative atomic mass, you will have 18.0. If I want to determine the mass of 1 mole of water, I just put the same value with gram as my unit. Next, for the molar mass of water, it will be 18.0 gram per mole. It's just numerically equal between them. Now, in 18.0 gram of water, I can say that there are 6.02 exponent 23 water molecules. But if I want to calculate the number of atoms, I will calculate based on 3 total number of atoms here, 2 hydrogen and 1 oxygen. So I will multiply 3 times Avogadro's number of water atoms. Next, if I want to determine the number of hydrogen atoms, we got 2 of them here, so it will be multiplied by 2 for Avogadro's number of H atoms. And last but not least, if I want to determine the number of oxygen atom, so I will have 1 oxygen atom only. It will be 6.02 exponent 23 oxygen atom. Please make sure that when you write in your answer, I want you to make it the final value for your calculation like this. In this video, I just explained to you how to calculate it, but when you put in your answer, please put the final value for this one and this one. So now, I hope you understand the relationship between mass, mole, and number of particles. When you have mass, number of moles, and number of particles, I put the number of moles in the middle of it, and you can interchange between Avogadro's constant and molar mass between 3 of them. This is the formula that you have to understand in order to calculate the number of moles. And you have to take note, everything must go through number of moles. It is very important for you to memorize the formula how to calculate the number of moles. Now, let's try example 3 where I have in 14 gram of nitrogen molecule, I have to calculate the moles, the number of molecule, and the number of atoms. The molar mass is given to you in units gram per mole. So let's go to the question 1 Roman. You have to calculate the number of mole. Please make sure when you do the solution, you put the subject for the thing that you want to find out. In this case, you want to find out the number of moles of N2. So use the formula mass over molar mass. You got the value already. So when you insert the value into the formula, you will have your calculation, and the final one you will get 0.50 mole of nitrogen. Now, we go to question 2 Roman. You have to calculate the number of molecules for nitrogen. In order to do this question, please memorize the relationship between number of molecules with number of mole by using Avogadro's constant. So when you rearrange the formula, you will have number of mole that you got from 1 Roman times with Avogadro's constant. You will have 0.5 times Avogadro's number. The final value you will have 3.011 exponent 23 molecules. Please make sure you emphasize the term behind it. What number is this referring to? Whether they are molecules or ions or atoms or particles. Settle for question 2 Roman. Let's go to the 3rd Roman. You have to calculate the number of atoms. You got here 1 molecule of nitrogen which containing 2 atoms of nitrogen. So, in order for you to calculate that, you rearrange the formula to find out the number of atoms, where you will have 6.022 exponent 23 atoms. This style of question is related to one another, and when you answering your question, please emphasize at the back of each number and make sure you put your answer at least 2 significant figures or 4 decimal places. Let's try example 4. In example 4, you have to calculate the number of hydrogen atom in 1 mole of NH3. This is very easy. First, if you don't know how to start, you have to relate with 1 mole of ammonia. So you got 1 mole of ammonia which contains 3 moles of hydrogen atom, because from its chemical formula you got 3 here for hydrogen. So I will write down that first. And after that, you can calculate the number of moles based on relationship between number of atoms with Avogadro's constant. So this will be your formula. You want to find out the number of H atoms, so please make sure you calculate based on 3 of them. So you will have 3 times 6.02 exponent 23, and the final value will be 1.806 exponent 24 atoms. Please make sure you have to emphasize here what number you are calculating for. Let's go to example 5. You have to calculate the number of bromide ions in 2 moles of CaBr2. Please be careful here. The number of mole is given here is 2 for CaBr2. So please try to write down a bit information here. So you got 1 mole of CaBr2 as general with containing 2 moles of bromide ion, because we have the chemical formula 1 mole CaBr, you got 2 mole Br ion from its chemical formula. So the first line is the general from the chemical formula. Now we are going to write the second line based on 2 moles. This is what the question asks for. So you will write down 2 moles of CaBr, which contains 4 moles of bromide ion. So when you want to calculate the number of bromide ions, you can write it down with equals to 4 times Avogadro's number. So you will have 2.408 exponent 24 ions. Here you emphasize this number is for number of ions. Example 5 is quite different from others. So in order for you to understand more, try to understand the general concept first based on 1 mole of anything that you want to find out. I leave try this one for you with its final answer so that you can enhance your understanding based on this video. So that's it for now. I'll see you in the next video.